How are you, my friends? This is lecture 14 of the pre-calculus course, Trigonometric Functions of Real Numbers. Here we will look at the unit circle and we will define the trigonometric functions using the unit circle. By definition, the unit circle is a circle of center 0, 0 and radius 1. So that's a very special circle. The equation is x squared plus y squared is equal to 1. Now to check any point on the unit circle, it's so easy. Just take the coordinates, put x here, square it, and put y there and square it. If they add up to 1, that means the point on the unit circle. That's a simple example here. Square root of 3 over 3, square root of 6 over 3. Is this point on the circle or outside the circle? Just little check here. You square the x, you square the y. When you add them, you get 1. So yes, this point on the circle. Now let's define, let's have a t be a real number and we have a point P, X, Y. See, this is a point P on the unit circle. So the point P determined by the T. T is this arc here. You see, this is from 0 until this point. This is the arc T. Now, by definition, we know from lecture 13, sine of T is equal y over r when we had the right triangle, cosine t x over r. The same definitions can be used. The only difference is this is radius 1, r is 1 here in the unit circle. So if r is 1, then sine of t will be the y, if you replace here r by 1, and then cosine of t will be the x. Now for sure, tan t will be y over x, because there is no r in the tan formula. Okay, so this is the t here. Now these are the summary of all the 6 functions. Sine of t will be y, cosine of t will be x. So we can use these formulas if we have the unit circle where the radius is 1. So tan of t y over x, cotan of t x over y, secant of t 1 over x, the reciprocal of the cosine, cosecant of t 1 over y, the reciprocal of sine. Now, just to remind you also, we had in lecture 13, the same table, we have special angles here, pi over 6, which is 30 degrees, pi over 3, which is 60 degrees, pi over 4, which is 45 degrees. So we have to know the sine, cosine, tan, cotan, secant, cosecant for all these special angles. Remember, t is the length of this arc here. See, since we have on the unit circle, so pi over 6, you can remember also the point for pi over 6, which is square root of 3 over 2 comma half. Also for pi over 4, you can remember this point. Pi over 3, you can remember this point. So always the sine is the y value and the cosine is the x value, as in the definition. Also in this slide, I put here the special angles and their multiples. See, if you have, let's concentrate on the angle 30 degrees, which is pi over 6. You see this one here. See, this is the red color. See, this one is the point square root of 3 over 2 comma half, because the sine of the 30 is half and the cosine is square root of 3 over 2. Now, if you have a multiple of that, will be 150. Angle 150 lies in quadrant 2. The same values, but only the x is negative, y positive. See, red, green, it goes to red here. 7 pi over 6, which is 210. The x here negative and the y negative, but the same values, only the signs are different. Also, if you go to quadrant 4, you will find the angle 330. Okay, so here x is positive and y is negative. You can do the same for the other angles. You can just review this, you can remember it, you can draw it. Now let's look at this example. Find the value of cosine pi over 3 plus sine pi over 2 all multiplied by secant squared pi over 4. Now, the only thing you have to do here is just to remember the table. So cosine pi over 3, the point on the unit circle is half square root of 3 over 2. I need here the cosine. The cosine is the x value. If I put here, let's look at sine pi over 2. See, pi over 2 is like 90 degrees. The point is 0, 1. So I need sine. Sine is the y value, see? Sine is the y value. The cosine is the x value from this point on the unit circle. Just remember, I mentioned that before, secant squared pi over 4, or you can have any angle there. It will be secant pi over 4 all squared. So you find the value, then you square it. Whatever, if you have a cube, you can cube it. So let's see now pi over 4. Let's continue. So pi over 4, the point in the unit circle, square root of 2 over 2, square root of 2 over 2. That means this is the sine and this is the cosine. Secant 1 over x, 1 over the cosine. So it will be only square root of 2. So let's put the values here. So this will be half. Cosine pi over 3, see, we know from last slide, is half. Sine pi over 2 is 1. So when you add 3 over 2, this one you square it, which is 2. The answer is 3. Now in this slide, we see the relationship between lecture 13 and lecture 14. In lecture 13, we had a right triangle. So we defined sine theta opposite over hypotenuse. See? So y over the r. Now in this lecture 14, we have sine t in the unit circle and r is 1. So y over 1 will be sine t is equal to y. Now this theta was in the right triangle. We used degrees. Now if theta is measured in radians, then theta is the same as the angle t. See, this is the angle theta, and this is the length of the arc. So we can use the same function values. Now, if we need to evaluate any trigonometric function for any real number t, we can use the same steps as in lecture 13, which is if the angle is greater than 2 pi or less than 0, then we have to find the coterminal angle between 0 and 2 pi. After that, so it will be either in quadrant 1, 2, 3, or 4. Then we find the reference, which we call it t prime or t dash. We called it in lecture 13 theta prime or theta dash. Then we find the trigonometric function value for the reference angle, t prime. Then we choose the sign, plus or minus, according to the quadrant where t lies. Now, let's find the reference angle first. We have here t5 pi over 6, t7 pi over 4, minus 2 pi over 3, and t equals 6 radians. Let's see the first one, 5 pi over 6. We have to locate where is 5 pi over 6. See, pi over 6 is 30. Multiplied by 5, it will be in quadrant 2. So that will be 150. Now, to find the t dash, it will be pi. See, this is in quadrant 2, minus t. So pi minus 5 pi over 6, you find the LCD, it will be pi over 6. So this is the reference here. See the reference? It's always between the terminal side and the x-axis. 7 pi over 4. Now we know 7 pi over 4 is in quadrant 4. See, every quadrant here, it has 2 pi over 4s because the quadrant is pi over 2. So 7, this is 2, 4, 6, and 7. So the angle is there. And then t dash, the reference will be 2 pi minus the angle t. So 2 pi is the complete cycle minus the angle itself. So you are left with 2 pi minus 7 pi over 4 will be 8 pi minus 7 pi. Pi over 4 is the reference here. Now minus 2 pi over 3. So minus 2 pi over 3, it will be in quadrant 3. That's in the negative here. So what can you do? You can find the coterminal. So 2 pi, you add 2 pi to this angle, you get 4 pi over 3. Now, if the angle in quadrant 3, we take the angle t, 4 pi over 3 minus the pi. See the angle here in the positive, 4 pi over 3 minus the pi, it will be pi over 3. So now the reference is here, t dash. Now 6 radians, only 6 radians. Where's 6 radians? If you make complete cycle, see complete cycle, it will be 2 pi. We know that. In radians, 2 pi. 2 pi will be approximately 6.28. Just before that, so that means we are in quadrant 4. See the 6 here. This is the angle before we make the complete cycle. So this is 6 radians. Now to find the angle t dash, it will be 2 pi minus the 6. That's t dash, only 2 pi minus the 6. Now you can find it in radians, 2 pi, which is 6.28 minus 6. You can say 0.28 radians, or if you convert it to degrees, approximately 16 degrees. But this is the correct answer here, the best answer. Let's see, find secant 11 pi over 6 times cosecant 21 pi over 4. This is a nice question. This one here is between 0 and 2 pi. See, there is no need, the first one here, there is no need for coterminal. This one, 21 pi over 4, this is more than 2 pi. How do you know? Just divide 21 by 4, simply. It will be 5 pi, more than 2 pi. Now, let's take it one by one. Find the coterminal if needed. So 11 pi over 6, we know it's less than 2 pi. No need for coterminal. But 11 pi over 6 lies in quadrant 4. So in quadrant 4, you can find the reference 2 pi minus 11 pi over 6. The 2 pi, complete cycle minus the angle itself. So it will be pi over 6. Now 21 pi over 4 is more than 2 pi. So let's find the coterminal. So we subtract here 2 times complete cycles until you get an angle here between 0 and 2 pi, which is 5 pi over 4. 5 pi over 4 is in quadrant 3. So the reference will be the angle itself minus the pi, which is pi over 4. Now let's put everything together on the next slide. We see this is the question here. Secant 11 pi over 6 times cosecant 21 pi over 4. So this one stays the same there, secant 11 pi over 6, because that's an angle between 0 and 2 pi. 21 pi over 4, we found already the coterminal, so it would be cosecant, the same as the coterminal. This is in quadrant 4. When we use the reference, you have to check the sign. Secant 1 over cosine. Cosine in quadrant 4, positive. So I said plus secant, the reference. Now look here. Cosecant 5 pi over 4. 5 pi over 4 in quadrant 3. The cosecant is minus because the sine is minus. Cosecant theta 1 over sine theta. So I have to put the minus times cosecant of the reference. So you have to put plus or minus. You have to check the quadrant. Now secant pi over 6, 1 over cosine pi over 6. And cosine pi over 6, I wrote it here for you, square root of 3 over 2. So the reciprocal will be 2 over square root of 3. And then cosecant pi over 4, the reciprocal will be square root of 2. Remember the minus here because of the quadrant 3. Multiply these two and rationalize. You will get minus 2 square root of 6 divided by 3. Now, even and odd functions, this is review from the algebra course, this slide here. Function is even if f of minus x is equal f of x, and this function is symmetric with respect to the y-axis. A function is odd if f of minus x is equal minus f of x, and the odd functions, they are symmetric about the origin. Just a review. Now for the trigonometric functions, two even functions, cosine, because cosine of minus t is the same as cosine of t, secant of minus t is equal to secant of t. These are even functions. You can apply this to any angle. And then the odd functions are the other four. The sine function is odd. See, odd function means sine of minus t minus sine of t. See the cosine, just compare the cosine and the sine to understand. Cosine of minus t, suppose we have cosine of minus 45 degrees. It will be the same as cosine 45 degrees. Cosine of minus 100 degrees is equal to cosine 100. But in the sine, you have to put a minus outside. Sine of minus 70 minus sine 70. Also for the cosecant, it's an odd function. Tangent is an odd function. T of minus t minus tan t. And the cotan is an odd function. Let's see an example here. We have a function x times tan x. We have to check if this function is even, odd, or neither. Also, we have to check the other function, f of x is equal to x squared times sine cubed. Let's see the first one. See, we know tan by itself. You see here, tan is odd, but you want to, this is x times tan x. That's completely different function. So we need to check f of minus x. That's the function here. So f of minus x will be, replace every x by minus x. So minus x times tan of minus x, leave this one. This is an odd function, we know that. So we can put minus tan x. So when you multiply, you get x tan x, which is the same as the function. So if we have f of minus x is equal to f of x, this function is even. See, the whole function now is even. Let's see the second one. Check f of minus x. Replace, see, I mentioned before, sine cubed, you can put sine x all cubed, always, with any power or any function. Replace x by minus x, so you have minus x squared, sine of minus x all cubed. See, inside, we know sine is odd function, inside the bracket. So I put minus sine x. See here, when you square it, you get plus. Now cube the minus and cube the sine. So you get minus 1 cubed, sine cubed. So there is a minus outside here. So now, since f of minus x is equal to minus f of x, the function here is odd function. Now, one way you can use these even and odd functions, if you have a negative in the angles, it's easy to deal with this minus. So let's find the value of this expression, square root of 2 cosine minus pi over 4 plus sine minus pi over 6 plus cotan squared minus 5 pi over 3. So anytime you see a negative, you can use even and odd definitions. Let's see here. Cosine of minus pi over 4. We know the function is even. See, this is the formula. Cosine of minus t is equal to cosine. Directly, it will be cosine of pi over 4. And we know that from the table or from the unit circle, square root of 2 over 2. Now look here. Sine minus pi over 6. Yeah, sine minus t. You have to put a minus sine the t. See, minus sine of minus t is minus sine t. It's an odd function. And we know sine pi over 6, half, and there is a minus, so it's minus half. Same thing for the cotan. Cotan is an odd function. Cotan pi over 3 will be 1 over square root of 3 with a minus. Now let's put everything together. See, this is from the last slide. These are the values. Just remember here, we have a squared. See, cotan squared theta, cotan theta all squared. I will mention this again and again. You can use this for any power or any function. If you have a squared or cube or any power on the function, you can raise it outside the bracket. So square root of 2 cosine minus pi over 4. See, this is the answer there. Square root of 2 over 2. And there's a square root of 2 from the question. This is minus. See, this is minus. And this one squared. See, the value here is minus. Cotangent is minus 1 over square root of 3 squared. Now, when you multiply everything here together, this is 2 over, this is 1. This is 1. This is minus half. And this is 1 over 3. So when you add the fractions, you get 5 over 6. This is a review of the fundamental identities. We have the reciprocal identities. We have seen many times. We have the quotient identities. Tan t is equal sine t over cosine t. Cotan t is the reciprocal also. And then Pythagorean identities, sine squared of t plus cosine squared of t is equal to 1. 1 plus tan squared of t is equal secant squared. And 1 plus cotan squared of t is equal cosecant squared of t. Now here is an important idea. You can call it also an advice. If any of the trigonometric functions is given, that means only one, with the quadrant where the angle lies, then all the other function values can be found. So this is example 6. In this one, given cosine of t 3 over 5, or any other function like tan, cotan, secant, cosecant, whatever. T belongs to quadrant 4. Let's find the values of the other trigonometric functions. So I will show you two ways. If you like here, cosine of t 3 over 5, I can use the formulas. See all the formulas that we have. Sine squared of t plus cosine squared of t is equal to 1. So I replace the cosine squared. Just be careful about the fractions. Take it on the other side. And then you get sine of t plus or minus 4 over 5. Now you have to check the quadrant. T lies in quadrant 4, then the sign is negative. So I can take sine t only minus 4 over 5. See, I have the cosine of t. I found sine of t. Then you can find the other 4. So you have to use the formulas. Sine of t is equal sine of t over tan of t is equal sine of t over cosine of t. Put the numbers, or you can say minus 4 over 3. Cotan of t will be the reciprocal, minus 3 over 4. Secant the reciprocal of the cosine, 5 over 3. And cosecant is the reciprocal of sine. Now, another way you can do triangle with x, y, and r, as we did in lecture 13. So this is cosine, this is x over r, and then you can draw a triangle, you can get the values, or you can use the formulas. Let's look at this nice question. The terminal point of t is given by square root of 3 over 4, comma y. Y is negative on the unit circle. See, I mentioned at the beginning of the lecture, this point on the unit circle. So just imagine the unit circle, radius is 1, this point is there. I gave you x, y is unknown, y less than 0. Find square root of 3 sine t plus tan t. So what do you have to do here? We have to find the y. So since this point on the unit circle, you just remember the equation of the unit circle. So I put x squared, square root of 3 over 4, all squared, y squared is equal to 1, then I find y. So y will be plus or minus square root of 13 divided by 4. See, this is 16 minus 3, 13 over 16. Take the square root of both sides. Now y is negative. See, so this is in quadrant 4. So I take y is negative. See, y is minus square root of 13 divided by 4. And then I know already cosine of t there, square root of 3 over 4 from the given. Now on the next slide, I have sine of t, cosine of t, then I can find tan t, sine t divided by cosine of t. So you divide them, you get minus square root of 39 divided by 3. See, this is the required now. What do we have to find? Square root of 3 times the sine. So there is a minus here, minus square root of 13 over 4. plus tan of t. Tan of t we found already. It's a minus square root of 39 over 3. So when you multiply this, you get minus square root of 39 over 4 minus square root of 39 over 3. You have to find the LCD 12. So the answer is minus 7 square root of 39 over 12. Now find example 8 here. Find the product of all the values of the angles in degrees satisfying the equation. Secant alpha is equal to square root of 3 over 3, given that alpha between 0 and 360. So from the given here, we see secant of alpha is equal to square root of 3 over 3. From there, we find cosine of alpha, because cosine is the reciprocal of secant. So 1 over secant of alpha will be 3 over 2 square root of 3. And let's rationalize here, multiply by square root of 3 up and down. So it will be 3 square root of 3, here 2 times 3. So the final answer will be cosine of alpha square root of 3 over 2. Now the angles here, they lie in quadrant 1 and 4 because the cosine is positive in quadrant 1 and 4. So we need to find all the alphas between 0 and 360. So the first alpha will be 30 degrees. This is in quadrant 1, and alpha will be 360 minus 30, which will be 330 in quadrant 4. So let's find the product of the angles in degrees. 30 degrees times 330 will be 9,900 degrees is the answer. Now I will leave for you some questions to practice, all the exams questions. Find the reference angle of these two, A and B. Find the reference angle of 10 radians. That's a multiple choice question. So the answers are there, A, B, C, D, choose one of them. And then cotan of t is equal to 4. Cosecant is less than 0. Find the square root of 1 plus cosecant square root of t plus square root of 34 times secant of t. Question number 4, let's find the exact value of this 10 square root of 6 sine 7 pi over 6 times cosine 675 degrees minus tan 38 pi over 3. If the angle is big angle, remember, greater than 2 pi or greater than 360, you have to find the coterminal first. Determine which function is even, odd, or neither. We have two functions there, 1 and 2. And then find the exact value of this sine minus 41 pi over 4 times tan 62 pi over 3. This is really nice question. In both here, we have to find coterminal, then the reference, then the values. If cosecant t is minus 2, t is in the interval 0 to 2 pi. Find the product of the exact values of t. See, we did similar example, the last example in this lecture. Now, express, this is the last question, express tan t in terms of cosine t, given that t is in quadrant 3. So you have to do something here until you find tan t is equal to something on the right side that has only cosines, cosine or cosine squared or minuses or numbers or radicals. See, like this one here, tan t will be the answer there. So these are the answers of the 8 questions and their parts. Now for complete solution, please, if you want to see the complete solution, you can go and see the video on trigonometric functions of real numbers, pre-calculus old exams questions, lecture 14. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 14. I wish I can see you in another video with another topic. Thank you very much.